All right, so for some extra practice, a little tie-in here for Chapter 6. National Health and Nutrition Examination Survey reports that the mean pulse rate for women between the ages of 20 and 55 are 74.5 beats per minute with a standard deviation of 12.2 beats per minute. Let's use this information and the empirical rule to describe the pulse rates of U.S. women. So we kind of left the empirical rule for a minute, and I want to kind of tie into what we've been doing. I have the x-axis on top, the z-axis, the standard normal distributions underneath. So these are the numbers that correspond to the z-scores. And suppose I wanted to know the percentage of U.S. women that have a pulse rate less than 86.7. So 86.7 is right here. Okay, less than. So all this would be what we're talking about here. Okay, so this is P of an X that is less than, the probability of an X that is less than a value of 86.7, okay, is what we're looking for, that number, okay? So we can use the empirical rule, and I just covered it up. Let me find the numbers right here. So the probability is all of these percentages added up. Or you could take these three and subtract them from 1. You're going to get 84%. Okay, if I add up all these, or take these from 100. What we were doing, you can sort of verify the z-score here of z equals 86.7 is the individual value, 74.5 is the mean over the standard deviation. And when you crunch those numbers out, you get the one that you would expect right here, because 86.7 is one standard deviation on the high side of the mean. Okay, and if you're looking for the probability of a z-score that is less than 1, you're going to go to the table, the positive table, right? It's on that side of the 0. You're going to go to the positive table, and you're going to go to 1, 0, okay? And you're going to go over just to 0, 0. And when you look there, it's going to put 0.8413. Let's go there for a second. This is the positive table. Let me erase some other things I had there. And we're going to go down to 1, 0 and 0, 0 right there. 0.8413, which rounds to 2 decimal places, is our 84%. Okay? And then it says, what if it's less than 80? So 80, let's see where 80 is here. All right, 80 is in between here somewhere. Okay, and if we're doing less than, this is all this here, and we will not be able to use the empirical rule. We can get an estimate to see, if our number's in the right ballpark, but since we're splitting, it's between, it's not all the way to 1 standard deviation, this 80 here. So if we're looking for the probability of x being less than 80, we have to do a little more work, and we can't use the empirical rule, okay? So z that corresponds to that, I'm looking for this right here, obviously less than 1 but greater than 0, so 80 minus 74.5 over 12.2 comes out to 0.45, which makes sense with our picture here. And if you go to the positive table, you go down to 0.4 and you go over to 0.05, you're going to get 0.6736, okay, or about 67% approximately of women have blood pressure, what's it, BPMs, pulse rates less than 80, okay? This is the work right there that I just explained, okay, with a little more step detail. If you can't read my slobby handwriting, sorry about that. Let's do some more with that same graph, okay? So just going to put the basics on this graph. If I'm gonna make this the z and this the x this time. So this is going to be 0, that's going to be 0, so it means this is 74.5. This is 74.5, and don't forget this was an x bar because it was a sample. So it still has its mean though here and its standard deviation. And we're going to look for below 60 beats per minute. So where would 60 fall? Well, 1 standard deviation. Let's remind ourselves, x bar was 74.5 and s was 12.2. So if you subtract 12.2, you're going to get 62.3. Subtract it again, you're going to get 50.1. So 60 is going to be in here somewhere and below. All right. So we're looking for the area or the probability of being less than 60. All right, so I need a z-score for this. So z equals 60, the individual point minus the mean over the standard deviation. And when you crunch that out, z is going to equal negative 1.19. Make sure you're rounding to 2 decimal places always for your z-scores so you can use the chart. All right, because we're going to go use the table and go down to negative 0.10 and over to 0.09. Do we need to do that on here? We're going to go, that's the positive. Remember, this is going to be on the negative side. So we're going to go down to, what I say, negative 1.1 right here, and we're going to go over to 0.09, which is all the way to the end here. So 1170. 1170. And because it's to the left, that's the number. Okay? That's for an x value of 60 or less is this was my 60, by the way. This z-score right here was negative 1.19, and the p-value is 1170. So what was the answer to the question? For 60 was about 11.7%. Okay. How about above 95? 95, let's see, on the upside, this is going to be 86.7, 2 standard deviations. Remember how we get those? We're taking the mean plus 1 standard deviation, then another standard deviation gives you the 98.9. So 95 is going to end up in here somewhere. So we're just talking about this little area right here. We want to know to the right, so greater than 95. Okay, so a couple ways you could do that. You could find all the way this way, or you could just subtract it from 1. So I need the z value. Let me get some of this stuff out of the way. I need the z value first. So z is going to equal 95 minus 74.5 over the standard deviation. That's going to come out to 1.68. So then I'm going to go to the table, positive table. That seems reasonable, right? Positive table to find this, and I'm going to find, go down to 1.6 and over to 0.08. I'm going to get 0.9535. That's from here over, okay? So I need to know this way. So I'm going to subtract it from 1, and I'm going to get 0.0465. So that's around 5%. Have above that. Okay? And then to do a between, this was 50.1, this was 62.3, so 55 is about here. I'm going to go ahead and get rid of some of this. This was 55, and 70 is in here. So we're just talking about this in here. So I need both z-scores, okay? So z equals 55 minus 74.5 over 12.2. That's going to crunch out to a negative 0.37. No, it's not, because the picture, that doesn't match the picture. Hang on. Let me check that. Because look at this, 70 is up here. Oh, I bet it's the 70 number that's 3 something. And the 55 is negative 1.6. That makes more sense. So this is one. That's why I like the pictures. So it's going to make sense. Look at this. 62.3 is at 1 standard deviation, right? It's past 1, so 1.6 makes sense for my z-scale there. And then apparently the other one is probably what I was thinking of. Negative 0.37. Okay, 70 is pretty close. It's not halfway like this picture looks, but it's pretty close, much closer to 74. So that makes sense. So this is, oh, negative, don't forget my negative 0.37. All right, now I am going to need numbers for each of these. So let's think. This way is going here. So the 1.6, we're going to look up the negative 1.6 on the negative scale, and we're going to find 0.0548, okay? And then we're going to look up this one here, because this is going to be the whole thing, and we're going to subtract that from it. So when I look up negative 0.37, I'm going to go down to negative 0.3 and over to 0.07. I'm going to get 3557. So I want to subtract away that extra space that I'm not talking about. Right here is what I'm subtracting away, right? So it's going to end up with 0.3009, so around 30% have blood pressures between 55 and 70, okay? The doctor's worried about both of the tails, the 5%, the highest and the lowest. Let's go ahead and keep our z up here and our x down here. So this is 74.5. We're using the same numbers. X bar was 74.5. S was 12.2. Lower 5%, wherever the heck that is. That's, assume it's down here somewhere. And upper 5%. So remember, if it's exactly the same amount, this is going to be a negative z-score, which is the same as this z-score on the upper side. So all I have to do is find this one. This is P5, or P equals 0.05, right, for 5%. And I need to work backwards to get my z. So I need to go to the negative table because it's on the negative side, right? I need to go to the negative table, and I got to find 0.05, all right? If we go to the negative table and find 0.05 right in here, that's where that little star is, I'm going to find out I'm exactly between, and you're supposed to go up. So this is negative 1.6 and 5. So this is going to give me a z-score of negative 1.65 going up to the 5. And then I need to find out what this is. So this z is negative 1.65. I need to know what this x is down here, that equivalent to that, okay? So we're going to use that other formula. All right, and we're going to put 74.5 plus our new z times our standard deviation. And this is going to come out to, since it's 1.5, we expect it to be low, right, but be below 62.3. So it comes out to 54.431, which makes sense because right here is 50.1 and right here is 62.3. So in the middle at 1.65, our x turns out to be 54.431, okay? The z-score up on this end has to match it because it's the same percentage away, so 165 positive, all right? So x equals 74.5 plus positive 65, 12, 2. That's going to give me, what do we expect? Well, we expect something, look at these numbers. There is 1 standard deviation, 2 standard deviations. We expect a number in between there, probably in the 90s. So when we crunch this out, we get 94.569, which seems reasonable. All right, so women with scores above this or equal to this or above are worrisome, and 54.431 equal to this and below are worrisome. Okay?